Alrighty, so hello and welcome. Here we are. Howdy. Good day. Um, Working on or returning to the problems we were looking at the other day. We're trying to. Wow, this is like maybe not the best. It's kind of funny. Just looking at this, I have like my I don't know. The sun is in my eyes, but also you could see it on the camera that clearly the sun is in my eyes, even with my shades closed. That's something funny about that. I don't know. That's okay. I don't. Hopefully, it doesn't matter too much to the audience. Um. So yeah, oh, you know what? Actually, I'm supposed to check my emails. I completely forgot. That's okay. I can check my emails a little later. What I want to do is return to some of the problems that we were working on the other day, and we were looking at Java. So I want to finish all these challenges for Java and just get that squared away because, like I said, I had an interview in Java and or an interview with a firm when they had asked me to program in Java, and yeah, it didn't go as I would have liked it to, and I was pretty disappointed. I was actually embarrassed. Um, so yeah, that was unfortunate. There's also, well, I just say I was embarrassed. I don't have to go into so much detail, but yeah. Okay, so let's keep going. Yeah. You're updating the username policy on your company's internal networking platform. According to the policy, a username is considered valid. Oh, so password complexity requirements. Is that what we're looking at now? Oh no, it's username. So it'd be username complexity requirements. Okay. A username is considered valid if all the following constraints are satisfied. The username consists of 80 to 30 characters inclusive. If the username consists of less than 8 or greater than 30 characters, then it is an invalid username. The username can only contain alphanumeric characters and underscores. Alphanumeric characters describe the character set consisting of lowercase characters A to Z, uppercase characters A to Z, and digits 0 through 9. The username can only contain alphanumeric characters and underscores. Okay, and so these are alphanumeric digits and lowercase, and uppercase characters. Fair enough. Alphabetical characters. The first character of the username must be an alphabetic character, either lowercase character or uppercase character. The first character of the username must be an alphabetic character, so it can't be a digit nor an underscore. Either lowercase a through z or uppercase character a through z. Okay. For example, Julia, invalid, less than 8 characters. Samantha, valid. Samantha 21, valid. 1 Samantha, invalid. It's a non-alphabetic character. Samantha question mark 10 underscore 2a, invalid. No question mark character allowed. Okay. Update the value of a regular so it is right. I was gonna say I was wondering if they would want to make you write a regular expression to do this, because while I think you technically can, I would prefer not to for something like this. I don't know. It's just like regular expressions. There's a few things about them that like I really would not prefer to use them for these kinds of things. Yeah, I don't know. I kind of don't like regular expressions in my code in general, I would say. And the reason for that really is just like the efficiency of it. It's like it's not the most efficient algorithm for doing certain things. It's reasonable for searching, but like if you're going to do a substring search, there are search algorithms to do that. If you're going to do like tokenizing or parsing, I mean, there's different kinds of algorithms for those things. Regular expressions actually have kind of like the real use cases of regular expressions. They're kind of limited, and they're also, for the cases that you might use them, they're somewhat inefficient. In my experience, yeah, which is a little weird, but not. I mean, it's not like it really matters that much, I guess. But personally, I'm not really a fan. I'm like, I think they're really interesting as a concept, but in practice, I'm kind of not too interested, I guess. They are really good for like text processing type applications, and I really mean like for me one-off sort of applications, like not even application, but just plain old, like let's say I'm taking a look through a file and I want to search for something and I want to use a regular expression to search. There you go. Like that's when I would use it. But I wouldn't typically want my regular expressions to be something that I'm using like in a very tight loop. I guess not a tight loop, but like in a very high, like where performance is extremely significant. Would not want to be running lots and lots of regular expression routines, subroutines, right? Or, so where something might be run repeatedly, something like that. Anyway, I'm kind of getting off base here. Let's actually try to solve this. So update the value of regular expression field in the username validator class so that the regular expression only matches with valid usernames. Input format: the first line of input caret contains integer n describing the total number of usernames. Each of n lines contains a string describing the username. Locked stub code reads the inputs and validates the username. For each of the usernames, the locked stub code prints valid if the username is valid, otherwise invalid on each new line. So I think, excuse me, I think it's just they just want us to write a regular expression. Oh, they really just right here, huh? Okay, pretty simple. Sure. Yeah. Okay. Fair enough. Fair enough. No problem. So I think this is just, you want at least, no more than 8 characters, but you can have any number of, you can have, I mean, oh, I'm sorry. It's got to be between 8 and 30. So there's a way to specify that. And since it's between 8 and, yeah, okay. All right. Let's do, excuse me. Let's look at the Java regular expression engine again. Java pattern is what we want to look at. So I'll explain in a moment what I'm looking to do here. I don't know if this is the most recent one, Java 7. I mean, hopefully, maybe it's the most up to date. But what we're going to do, there is a quantifier, I guess is what we're looking for. So there's at least n times, there's exactly n times, and there's at least n but not more than m. So we want to use that, or make use of that. It's usually braces. Yeah, it looks like braces. So that's to get us our 8 to 30. However, the first character, I think we're going to use only alphanumeric, so A to Z, A to Z. Yeah, okay, let's do that. So it's got to be at least one. I mean, there's always at least 8 characters, so we can always just do one character. So there's A to Z. I think you could do these. Do it this way. And there's at least one. And then you can say, I think you could do it that way. I think that's fine. And then that's the first character. And then A to Z, 0 through 9. And this is going to be 7 to 29. Something like that. I don't know. Let's see. Does this work? Let's compile. Wrong. Okay. Which one is wrong? Oh, I'm missing underscores. Yeah. All right. How do we do? Okay. I think we got it. Do we just go for it? I don't know. I'm kind of nervous to just go for it. I think that's it. Like, I think it's really that simple. There's always got to be at least one character because there's at least 8. So we can always specify the first character. It has to be one of the alphabetic characters. And then there's 7 through 29 other characters. And there's at least 7 of them, and that's it. And these are the only characters that get underscore and alphanumeric. All right. I mean, I don't know. Maybe. Hopefully. Okay. Got it. Fair enough. Okay, next. Tag content extractor. In tag-based languages, in a tag-based language like XML or HTML, contents are enclosed between a start tag and an end tag, like tag contents tag. Note that the corresponding end tag starts with a /. Given a string of text in a tag-based language, parse this text and retrieve the contents enclosed within sequences of well-organized tags meeting the following criterion. 1. The name of the start and end tags must be the same. The HTML code h1 hello world h2 is not valid because this text starts with an h1 tag and ends with a non-matching h2 tag. Medium. Okay, interesting. Tags can be nested, but content between nested tags is considered not valid. For example, in h1a contents a invalid, h1 contents is valid, but invalid is not valid. Tags can consist of it. Oh, fun fact. I don't believe you can parse XML or HTML in I don't believe you can do it using a regular expression. While we were just talking about the limitations of regular expressions and their use cases, that's one of them. It's not sufficient for XML and HTML parsing. Tags can consist of any printable characters. The first line of input contains a single integer n, the number of lines, the n subsequent lines each contain a line of text. Each line contains a maximum of 10,000 printable characters. The total number of characters in all test cases will not exceed 1 million. I believe it's 1 million, yeah. Okay, sure. Oh, I see, okay. Excuse me. For each line, print the content enclosed within valid tags. Actually, you don't really need this here because 100 times 10 to the 4th. Oh, yeah, 100 times 10 to the 4th is 10 to the 6th. So it's obviously this is true. It's inferred from these two facts, but that's okay. It's fine. So for each line, print the content enclosed within valid tags. If a line contains multiple instances of valid content, print out each instance of valid content on a new line. If no valid content is found, print none. Excuse me, this is actually not the most simple thing in the world. I mean, I have an idea. I could probably use a stack to do this, but still don't like it, I guess. Naeem loves counseling. Sanjay has no watch. So wait for a while. Safat codes like a ninja. Imtiaz has a secret crush. Sample output. Naeem loves counseling. Sanjay has no watch. So wait for a while. None. Right, so this is wrong because it's case sensitive. And MT has a secret crush. Okay, so print none if there's no content. All right. Sure. Okay. So write your code here. So we probably want this routine to be its own routine because this is kind of an involved thing. We're at that point now where we can write our own subroutine. So we'll say a string, and we're gonna say parse HTML or HTML. We'll say. And I don't know if you actually need this for classes in Java. If you need the private classes or private methods, rather, private method. So, yeah, we just print that result. Parse HTML. Line. Okay. Okay, it's line by line. That's fine. That's fine. All right. We're going to use a stack for each tag. I think that's the most appropriate thing to do. And basically what we want to do is when we see an identifier, we
push that onto the stack. When we see, so I really it's the opening, an opening. So really it's two characters, right? The opening greater than symbol, and then the next character. If the next character is a /, then we know that we can say that that's a closing tag. If it's not a /, that means it's a new tag. So we're going to push that new. We're going to enclose to retrieve the tag. We want to see our next closing bracket. Greater. Really, excuse me. This is less than symbol. I'm sorry. The greater than symbol. So when we see a less than symbol, when we see a greater than symbol, we know we can enclose those characters into a tag. Sure. I don't know. I'm kind of like, I guess it's like almost like a state machine type of thing that we're going to be running through here, sort of. Not exactly, but I don't know. It's just code. Yes, let's just say it's code. Like I said, regular expressions actually are not sufficient for XML, HTML parsing, or XML parsing. So it's so we can't actually you really can't model it with a state machine then, because that's effectively what a deterministic finite automata or DFA or regular expression. These are all like related to each other. So we'll not call it a state machine. Although I think a state machine is not necessarily a DFA, but like it's very similar, I guess. Depending on the context. So anyway, right, we want to push a tag, and then everything inside of that tag would be considered. What do you call that? Would be considered content. And then now what can happen is you find a closing tag which you need to match to the top of your stack. If it's the wrong, now here's a question. If this is an incorrect tag, content between nested tags is considered not valid. Okay. This is not valid. So I guess my question is, if you put an H2 here, but then you put another H1 at the end of that, technically that content in between, I guess depending on how you define things, could be considered valid content. So I kind of need some clarification on that one, like whether or not this closing tag would actually would just cause this altogether to be invalid. Basically I guess erase. Like I'm trying to think. Because you could maybe have invalid tags and then have valid tags following, right? In theory. I'm actually not really sure. Tags consist of any printable characters. Are we going to get tested on whether or not the characters are not printable or not printable? Because that would suck. That would be awkward. I hope not. I hope I don't have to check for non-printable characters. That would be really awkward. I don't think I can solve this one off the bat because there are too many questions that I have. There's too many situations that I would need to run. There's not enough definition here. There are too many questions. Questions like this kind of are supposed to be open-ended, but the problem with that is that the reason that interview questions are open-ended is because you can ask the interviewer if you're just working with something someone wrote and there's nobody there to respond with your questions. I mean, I can go to the discussion, but that tends to give away the answer. It's just not really what we want to do here. I want to try our best not to open the discussion. All right. String of text in a tag-based language. Parse this text and retrieve the contents enclosed within sequences of well-organized tags meeting the following criteria. So the question I have at the moment is if it's not well-organized, do we just write none, like the whole thing's invalid?
Excuse me. And like, if we like this is a good example. Like, do we print contents here, or do we just say the whole thing's invalid? Contents is valid, but invalid is not valid. Okay. So I guess any content between invalid tags is just gone. All right, we just remove that from the buffer, so to speak. And then what? Do we wait for? So that's a good question, right? Like, do we pop H1 altogether, and then when we see the H1 tag, just disregard it, or because you could put more content here to the right of H2, and then have the rest of H1 show up, and then you have to wonder what are you supposed to do with that. Yeah. That's ambiguous here. Excuse me, what the rules they've given here, you have to assume what to do in that case. Well, we know the content between not matching tags is invalid, and then I guess all of the content after that is like how far do we go until the content is valid again? I guess it's maybe the question. Like, can you put an H2 here and here right after following this string? Between two H2s. I don't know. Do you just stop if you have some invalid HTML? Is that it? I don't know. Print the content included with invalid tags. Interesting. Well, I think the best thing to do is exactly what they just suggested. Excuse me. So if H1 has a tag before the other H1 and it's invalid, excuse me, then you would erase characters, I guess, until you see another token that you might use. And you basically either ignore H1 or pop H1 and just do it that way, I think. Because you could have just you could just never finish H1, I guess. And that's fine. It'll just sit in your stack, at the top of the stack. Or at the bottom of the stack, rather. Yeah, I guess you would just keep scrolling until you find a... we don't really care that much about the stack state. If you find an invalid tag, you basically would sort of just keep scrolling until you find another opening tag. I think that's probably the way to do it. So we'll do it that way. All right. So my thinking is the following: we parse the line character by character, and we'll have like a different states of like sort of what we're looking, what our function or program is looking to do. So we'll initially be looking for a tag, or for an opening, a less than symbol. Throw out everything until we see a less than symbol. Then once we do see a less than symbol, then we go to a different state, which is going to be now we're looking to I guess the state's going to be looking for a tag is the state that we're in. So we start off in a looking for a tag state, throw out characters until we see an opening, a less than symbol, and then all the characters until we see an opening symbol, which is, we can say look to open tag, maybe is what the state is going to be. And then if we're look to close tag, right? So we've opened a tag, look to close tag. We're going to be gathering characters until we see this greater than symbol, right?
and then that'll give us a tag. We can push that onto our stack, and then now we're look for a closing tag, right? And in that state, we're going to collect characters until we find a less than symbol again. But again, the state that we're in is looking for a closing tag. And then if we're looking for the closing tag state and we have a less than symbol, then I guess we're looking to validate a closing state, and we're going to look for a forward slash. The thing that's tricky here is if there is a forward slash, then the state that we're going to go to is, I guess, not just validating the closing tag, but now we're, where did I say this was? I was looking for an opening tag, and then looking to complete the opening tag. I guess completing an opening tag. And then this is, we validated our closing tag. That was, we're looking for a closing tag, validate closing tag, and then complete the closing tag. And in there, you're going to be looking for the opening, the greater than symbol. Now, what's tricky here though is that once you've got your tag, you would store this content in a string somewhere, stored in a buffer, and then once you've got the closing tag, if that closing tag doesn't match the top of the stack, then we have invalid content, and we would dump it. And then I think we would just look for an opening tag again, and toss out any characters until you find one. I think we now what's interesting is that you can't have content between nested tags also, which is really interesting. I don't know. We don't necessarily need a stack for this, actually, if that's true. Because you can do a substring search for this, and then just take everything between these tags. I think we'll keep going with the idea that I have. So then you can, as I said, so you can have like multiple states, right? One state is look for an opening, an opening tag, then look to complete that tag, then look for a closing tag, validate that closing tag, look to complete that closing tag, and then obviously if it matches the top of the stack, these two tags, you could pop the stack, and these contents could be put on the new line or on a line, and obviously or a line with the new line character. Well, I guess a new line. Yeah, let's just say a new line. That's actually kind of a tricky thing. We would want. Well. Yeah, I guess the first instance would not necessarily have a new line character, and then everything after the first instance we could say we add a new line character and then the new line. Everything after the first instance will be on a new line. So then now if it's invalid, this tag doesn't match, then you don't pop anything. And you just change your state to searching for an opening tag. And even if you do pop something, you're still going to be searching for such a tag. Now, I think something we need to
be careful about also is that when you are, there should be actually a validation step also on the opening tag, in that the next character needs to not be a forward slash, because that makes it a closing tag. So if it's an opening tag and we find a forward slash in the second character, the next character, then actually we have a we haven't found the opening tag. And actually, if you're looking for an opening tag, you basically would go, if that validation step fails, you go back to looking for an opening tag again, I think. Which is really confusing because you can break that. There are test cases you can make that would kind of make that look silly. Like, you need to actually find, you actually need to complete the tag, I think, in that case. So I think actually in that case you would say that you're really just looking for a closing tag. Yeah, a closing tag. But then the problem with that I guess you could switch it to a state of like a like a broken closing tag, something like that. Yeah, because you don't want to have like multiple less than symbols and multiple greater than symbols, and you just get this really confusing mess. You don't want to call that a tag either. I think that's probably should just be invalid. Like the tag names could begin with. It says tags consist of any printable characters though, which means you could actually have like multiple sort of tags within the tag, if that makes sense. So you could have like the tag itself could be the greater than and less than and then greater than symbol, in which case you'll get I mean, yeah, then it just looks really funky, really strange. But I guess you could do that. I mean, if this is actually the rule for the tags, it could be anything. Then they just can't be tags that start with a forward slash, right? I mean, that's the thing. It's sort of contradictory. That's something I really don't like about Hackerrank, in my opinion. I think it's not very careful about some of the things that are stated. It's actually like really ambiguous. Like that. This actually is a contradiction, right? You can't have the way that this is written. You can't actually have any printable characters for the tags, because if you put a forward slash as part of the initial tag, then you can't really tell if this is an invalid tag, right? So if you did like H1 and you wanted your tag to start with a forward slash, and you made this H2, you couldn't tell that tag apart from the beginning of a new tag that starts with forward slash, or if this is an ending tag for H1, right? If you wanted to have a nesting tag or not. So that's actually not correct. Yeah. Go lay down now. I want to go lay down and take a nap. I really dislike ambiguous questions like this, where it's hard to understand what they're asking for, what they want. You know, with other websites, like I said, with LeetCode, you can run your own test cases to see what the output's supposed to be, and you can actually answer those ambiguous questions. You don't actually need to rely on the author completely. But in this case, I can't just try the different test cases and see if they fail or not, which is really annoying. Even though I can have my own input, it doesn't tell you what the result for this custom input what it's supposed to be. So if I just run like some random thing in here, let's see. Something like this. I would want to know what's supposed to be printed here. Sorry. Oh, that's why. Or not. Oh, it's a static. Okay, sure. Fair enough. Exception. Number format exception. Wow. What? Excuse me? Oh, you need to have the number of lines. Yeah, that makes sense. But yeah, it doesn't tell you what it's supposed to be. It just tells you that it didn't crash. It doesn't tell you what the output, what the expected output is, which should be really helpful. It should be really helpful. But to know that, right? Because it's ambiguity in the question. That's kind of annoying. All right. So what about the test cases? Maybe they give some examples. Excuse me. Whoa, 99 of these, 90 of these. Okay. Well, that maybe covers some cases. Just random input. Okay. That helps. Actually, maybe these different questions are answered in these test cases. Hopefully. Okay, so had public. So this. Oh yeah, what happens here? That's a good question. What do we get for number the second one? Public. So public is valid, even though this is not valid. Oh man. Oh boy. Oh, I don't think the program was gonna write would have got this one correct. Excuse me. I think if I can get through these three test cases, though, I probably have the right idea. So this one should be none, right? 1, 2, 3, 4. How about? So what I was thinking. Okay, so we would gather had, and then as soon as we see another tag, right? Actually, this would handle fine. This would basically on this. I guess on this the previous stack. Now I think they were saying that things between tags just get tossed out. So actually, if you end up here, then you actually could just reset the buffer back to nothing again. I think that's fine. You could argue like, well, if you're gonna open this tag, close this tag, and then return, then you could. Excuse me. Oh, I'm very tired. Open this tag, close this tag, close this tag. You could actually put the buffer on a stack as well, so that when you pop both stacks, and print this line and then return to what you had. But actually, we're going to clear the buffer every time. So yeah, actually, my program would work here. It's just we would pop this stack, and then I think if you, yeah, okay. You're really not on a stack anymore, though, are you? If that's the case, if things can be nested, but there's nothing in between the nested tags matters. I think actually in that case you don't even have a stack anymore. You just have a single tag that you're searching for, and that's it. So here's a good example. So you have had h1 public h1515. This second tag doesn't come out properly, so then this doesn't pop, and then what? I guess you're now I get no. Okay, so here's a good question. Does this whole thing get contained and get printed? I don't think so. So 1, 2, 3. Right? What does the third one give us? Nothing. Right. So yeah, you end up throwing out. So you have a tag that, right? You have a less than symbol, and then from there you're just looking for the tag, and then you have a greater than symbol. That gives you your tag, and then now you're picking up characters until you see that tag again, but the closing version of that tag. If you see another opening tag, you toss out everything that you previously had, the other previous opening tag, and the buffer for the string. And then again, you're going to parse this tag, close it, right, or complete the tag, and then fill your string buffer as you go, and then you have another tag. You're going to validate the tag if it's an opening tag or closing tag. If it's a closing tag, that's what you want. If it's an opening tag, then again, you just throw everything out. But if it's a closing tag, then you're going to want to get the rest of the tag, and then you compare that to your current opening tag. If the tags match, then you can print your buffer, or you can use your buffer, save your buffer. If they don't match, then I think you toss everything out again and search for an opening tag again, and really just throw everything else out until you find that opening tag. Yeah, even if you see a closing tag, you don't even process it if you're looking for an opening tag. So I guess it's like a find opening tag, something like that. So here, these tags are nested, but we don't really even care about the outer nest portions. This part was super curious to me. This is what I was kind of saying, that these are technically, this is one gigantic tag here, and then there's another tag here, but these tags don't match. And yeah, I guess that's why I asked, because you can make a tag like this. These just are basically just two opening tags, neither of which have any closing tags or any characters in between. I'm sorry, I take that back. This is an opening tag all the way up until this point. And then these are characters in between until you get another closing tag, which then this closing tag is all the way here. This tag. So there is something between this one and this one. It's this tag, and it's really this tag and this tag. Now the question is how many. Now clearly though, this is too small, right? These tags don't match, so all this gets thrown out, and then this ends up being. Actually, no, you end up starting a new one here altogether, because you don't have a closing tag. I mean, there's no closing tags here, so it doesn't matter. So it's just really just opening tags over and over again a few times. Interesting. So that's a none also. All of these are none all the way down to the bottom. So that doesn't work. Oh, I'm sorry. These are each on different lines. Okay, well, I think it's the same idea. This never closes the tag. This never opens the tag, or begins the tag. This never completes the tag. This never begins the tag. This, maybe you could have something, but I don't think so. I think they don't match the tags, the size. And then these you need to have something, some character in between. You can't have an empty tag. I guess that's what's going on here. And then this hello again, nothing. Actually, this would be the entire tag, which is very confusing. But that would actually be the tag, because you're looking for. Well, I don't actually know. Yeah, you can handle this a few different ways, and it would still give you the same answer. You could say this actually closes the tag, but because it's an empty tag, it gets thrown out, and you're still looking for another tag. So you throw out all these characters, then you see this, and you say, okay, we're still looking for a tag, but this is a closing tag, not an opening tag. We're looking for an opening tag, and then so you throw this one out too. But you have to actually complete it also, I think. It's kind of another question here. It's like, do these count as just gibberish characters, or do you need to actually complete the tag to count it as gibberish? As I said, another question. I think all these test cases, I think it'll come out some of these things. Also, I don't know. I said it needs to be printable characters for the tags. I hope they don't test me on that, because I mean, I know how to do that to make sure they're printable, but I don't want to do that, add that extra step to ensure that it's a printable character for the tag. So now, yeah, who knows? Maybe there's non-printable characters here and here. Maybe that's what's going on. So then finally, you're still looking for an opening tag, and then you get the opening and closing tag, and then you can print these contents. And then same thing here. This gets thrown out, opening, closing, and then you're looking for an opening tag again, but you never get it. So, yeah. Okay. Excuse me. So, for the record, I strongly dislike this question. This is obnoxious. This is the most ridiculous thing. And really, it's... This is empty. I need to add an extra... this doesn't really need to be here, does it? Yeah, we just add that there. So, okay. I'm going to say string buffer. I'm going to say current tag. And we're going to say Boolean search for opening tag. True. Really, we want like states here. We want like an enum kind of a thing. Entering different states as we parse, and then have different rules for different states. So all right, let's look up enums in Java. Let's do it. Excuse me. We're just going to say like parse state. We're going to say searching for opening tag, search validate tag. Now we're going to validate the opening tag. We don't want and then completing opening tag. So if we are searching for an opening tag, we're looking for
less than symbol, and yeah, we're looking for a less than symbol. And then if that's our state, once we find that less than symbol, then we want to move to the validate opening tag, which is then going to search for, make sure that the next character is not a /, and yeah, it's not a /. If that character also happens to be a closing tag, which is the greater than, the greater than symbol. So the less than symbol, if it's the greater than symbol, then we immediately have completed our opening tag. But our tag is empty, and then so we just jump right back to search for opening tag again. I think that's fine. But yeah, so our validate opening tag really looks for two things. We're looking for that we're not the / character, and if we happen to also be the greater than character, then we're going to just jump immediately to searching for an opening tag, because we can't use empty opening tags. That's a validate opening tag state. The completing opening tag is if we pass the validate opening tag, that character is going to be moved to our buffer, and then now we're in the completing opening tag state, and we're looking for a greater than symbol. All the symbols that we see that are printable characters would be added to our buffer, appended to our buffer, and until we find the greater than symbol. Once we find the greater than symbol, then we've completed the opening tag, and we're going to move to the searching for closing tag state at that point. And our buffer, we're going to add characters to our, so we have our tag buffer, so we have our content buffer, and we have a tag buffer. Excuse me. Now we're searching for a closing tag, and we're going to add every character we see that's not a less than symbol to the content buffer, right? Append that to the content buffer. Once we see the less than symbol, now we're in the validate, and we're going to move to the validate closing tag state. And that validate closing tag state now is looking for a / character. Now, what's tricky about this is that the closing tag could be an opening tag also. So if the / character is not there, it could be a couple of things. So if it could be not the / character, in which case we're actually now basically looking to complete an opening tag, and we're going to flush the tag buffer and flush the content buffer, right? So they're, or just empty those two buffers, and we're now looking to complete an opening tag. We're basically starting over. If it's a closing tag, though, it could be it's not a / symbol, and then we're doing what I just suggested. But also it could be a greater than symbol, in which case we just immediately jump to the searching for opening tag again. That's basically an empty opening tag that we just found. So if we're in that case, we're just going to jump back to an opening tag. But if we're not in that case, then we're going to start to complete the opening tag. If it's not a /. If it's a /, then we're going to complete. If it is a /, then we're going to complete the completing closing tag, right? So depending on what we get when we're validating our closing tag, we could be in the completing closing tag, we could be in the searching for opening tag, we could be also in the completing closing tag, we could be in the searching for opening tag, and we can be the completing opening tag states. And then the completing closing tag is similar to the completing opening tag, where we are looking for the a greater than symbol. And then once we found it, then we've in theory completed this tag. All the characters in this state we're going to add to our open tag buffer. It should be in closed tag buffer. We should have two. We should have opening tag buffer, and a closing tag buffer.
And yeah, I guess when we flush our buffers, we flush all three of them in case there's anything in the closing tag buffer. And so we're gonna be in our completing closing tag buffer, every character after the /, we're going to add those characters to the closing tag, append those characters to the closing tag buffer. Then once we've completed the closing tag buffer, closing tag, that means we've found an opening, a greater than symbol rather. Then we take our closing tag buffer, compare it to the opening tag buffer, and if those are equal, then we take our content buffer, and what we're going to say is if ret is empty, then we set ret to that content buffer. Otherwise, we append a new line character to ret, and we append the content buffer to ret. And that's how we build our line by line, the contents that are valid. So yeah, I think that's how we're going to do it. Sort of a state machine type thing, character by character, moving from one state to another, one parse state to another, and yeah, doing different logic depending on the state and what we've just seen. And I think that works. I think that's fine. I think it's sufficient. So we'll try that. We will try that. I don't know if you can do like something like this, like 4 characters C and S. You can do this in C++, but I don't think you do in Java. I might convert the string to a. I might convert the string to a. What is that called? I might convert the string to a character array and process it that way. What happens if we do this? Does this compile? Let's start with that. No. Not applicable. Really? Can we iterate over the string? How do you do that? Java, iterate over a string. Yeah, strings in C++ are actually like character arrays, and they're mutable. They're not. I mean, the string itself is immutable, but the string object, the string array, character array is mutable. Yeah. 'Yeah, that's what I'm saying. I don't want to copy things. %2 faster iterating by index. Character at, that's what you do. Okay. Awkward, I know. Oh, this is really bad. Don't do that. Substrings are not that efficient. Don't do this. Really, character at. Okay. That is very awkward. The compiler will optimize out, I think, the get length function. I think I could be wrong, but it's not really that inefficient to do this. I suppose. I think. I hope. I actually don't know. I'm assuming that it would. Get at, or is it get character at? close it? I think we did. Let's probably get character at. Or not. Oh wow, I cannot seem to spell, huh? Okay. So JDK 11. Yeah, car at. Oh, it's not get at, it's character at. Okay, got it. That's what I did wrong. Okay, it compiles. Alright. Oh, wait, TLE. Did not execute within the time limits. Really? That's really interesting. What is going on there? What? How's that possible? Whoa, 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 whoa. What do you mean? Oh, that's why. Because we print. Oh, I understand. Because we printed everything. That's why it's slowing down. I was thinking, like, hey, man, if you can't even just loop over the string, it's not going to work. You don't have it's not enough time. It doesn't have the time to loop over the string. We have problems. But actually, it's the printout that's causing issues. Printing every single character on a new line is too slow. All right, so this will work. I mean, this is not the prettiest thing, but it works. I sneeze. Excuse me. All right, so sure. Okay. So we're gonna get our character, and then we're gonna have our parse state is so we call it current state is a parse state. And the initial state for the current state is going to be searching for opening tag. Let's see if this can compile. Enums can be kind of strange. Yeah. Okay. So just parse state dot. I don't actually know how to set this up properly. Looks like you can do. For some reason, you can just use Monday as it is. Just strange. Day.Monday. Yeah, it should be day.Monday, not just Monday. I don't really know why. I don't know why Monday here would be fine and it wouldn't be day.Monday. But okay, so I guess I don't really know, but that's fine. Okay, so parse state searching for opening tag, and then we can say switch on the parse current state. We'll say case parse state dot searching for opening tag. We're gonna okay. And we have 6 of these, right? Break. 1, 2, 3, 4. So we have 1, 2, 3, 4, 5, 6. Searching for opening tag. Validate opening tag. The next one is closing, completing opening tag. The next one is searching for closing tag.
And the next one is validate opening tag. And the last one is completing closing tag. Okay. All right. So we have searching for opening tag, and then we have validate opening tag, completing opening tag, searching for a closing tag, validate the closing tag, completing the closing tag, and you have all these different cases. And there's usually a default case, but I don't really know what we're going to do in a default case. We should always be in one of these states. Now, effectively, that's pretty much it. Return ret, and from here, perform all of our operations in each of these cases. So, if we're searching for an opening tag, then we say if C is the less than character, then we have things to do, otherwise do nothing. If we do see this character, then we're going to set our parse state to our current state rather. Parse state dot validate opening tag. Okay, I don't think we do anything else here though. We're searching for an opening tag. Don't think there's anything else to do. Validate our opening tag. We want to say if C is equal to the closing, the greater than, then we're setting our current state back to not validate tag, but searching for opening tag. And we're also going to set these buffers to 0. Content buffer gets dumped. Opening tag buffer is dumped. Closing tag buffer is dumped. Dump our buffers. Otherwise, we can say if this is a /, then also we're going to go to the searching for or completing closing tag. Now, what's interesting about this is we're gonna complete this closing tag, but we're also going to dump this tag. So even though we're searching for an opening tag, we still need to complete the closing tag and then throw it out, which is kind of awkward. That's actually something I'm kind of unsure about or confused about. So, well, if you're looking for an opening tag, searching for an opening tag, all the characters get thrown out anyway. So actually, I think you don't need to complete this. I think you can just go, you can do the same thing here. In either case, I think both of those work. You would dump your buffer, dump all of your buffers, and now you're searching for an opening tag. And what'll happen is, now, actually take it back, because what if your tag itself, what if your tag itself has, what if your tag itself, it's a closing tag, but it contains an opening tag, sort of opening tag semantics? You have a problem there, right? Because then you're supposed to close that tag. So yeah, so you actually don't dump I think you complete the closing tag, but you do dump all of your buffers because you're getting a closing tag when you're expecting an opening tag. Yeah. Yeah, so I think you do dump your buffers. And the thing about this though is, because you dumped your buffers, it's not possible for you to compare this now. Yeah. What's really tricky about this, well, yeah, I guess once you've completed a closing tag, if the closing tag is empty, then we don't compare it to the opening tag. We should do it that way. Yeah, I think that's fine. Just don't compare it. Have that extra statement in there. Now, if validating our opening tag and we're not immediately closed and we're not a closing tag, then all these characters after that we're going to go to the completing state. Completing opening tag. Yeah, now we're going to complete our opening tag. Okay, from the completing opening tag state, we say if we're not for the closing tag, if we're anything other than the closing tag, we're going to continue in the completing opening tag state and just update the buffer. So there's tag buffer plus equals C, right? Super simple. Excuse me. But when we're here, now we're going to be searching for closing tag. And we have our tag buffers already set up. Content buffer could be set back to 0. Right, we're going to start filling that content buffer once we complete that opening tag. And then the opening tag buffer has been modified, has been set. And we can reset our closing tag buffer to empty again. That should be fine. Yeah. Yeah, it should be it for searching for completing the opening tag. Now that we're searching for a closing tag, it's going to look very similar to the opening tag, except we're going to fill our content buffer as we go. By the way, I think questions about parsing XML and HTML are like typically not questions you'll see in interviews. I think these questions are a little bit too challenging, in my opinion, like too much time. It's not that they're too hard, it's too much time involved trying to figure out all the states and things and moving between the states. It's not like you can't, but it's like I said, it's in my opinion, it's not the best question to ask. So now this is the content buffer that you're going to add this character by character, and until you see the less than symbol, right? And once you see that less than symbol, now you are validating the closing tag, and otherwise you're just adding stuff to the content buffer, which I think is fine. Once you validate a closing tag, then you say, that's very similar to the validate opening tag. It's very likely certain test cases that I'm working on here are just not going to be correct because it was somewhat ambiguous. Without the test cases, with the test cases, it's a little bit less ambiguous. So now validating a closing tag, we're looking for this character. If we immediately close, then I think, yeah, we're also going to be searching for an opening tag. And if you're validating a closing tag and you close it immediately, you have kind of a problem. I guess you're just looking for an opening tag after that, because you're really just looking at an empty closing tag, and you just reset everything. I think that's fine. If you do see the forward slash though, so now you're going to be completing the closing tag, which I guess is the same thing as the validate opening tag. So now you're going to complete the closing tag, and in this case though, your content buffer doesn't change. This is actually what you're supposed to, like, this is the sort of correct flow. And then your opening tag buffer doesn't change, it stays the same. And your closing tag buffer doesn't get erased either. It's actually going to start getting filled after that point. If you're not the forward slash and not this closing symbol, I think actually you're going to end up here, right? So this means you're actually looking at another opening tag. In which case this is an opening tag at this point. You would actually go to closing an opening tag, or completing an opening tag. Which is kind of interesting. Now notice we're not checking for printable characters here. There's a few key points here where we check for printable characters. Once you're looking for an opening tag, you're completing the opening tag, you're dropping the content buffer, dropping opening tag buffer, and dropping the closing. Everything just gets dropped at that point when you're validating a closing tag. Now when you're completing the closing tag, it's very similar to completing the opening tag, except a few key points. Yeah, like this is way too much logic here. It's like way too many cases to pay attention to. Completing the closing tag is, you're looking for the greater than symbol. Once you have, you're actually going to be searching for an opening tag once you do that. So once you're done. Excuse me. And so actually you have completed the closing tag at this point. What you're going to do is say if the closing tag buffer is not empty. So the closing tag buffer is not empty, and the opening tag buffer equals the closing tag buffer. Then we're going to append if the closing tag buffer is not empty and the opening tag buffer is equal to the closing tag buffer, meaning that we found something in the tags, then we're going to say if the content buffer is not empty, actually we can even content buffer. And the content buffer is not empty, then we're going to say if ret.equal, if ret is empty, then set ret equal to the content buffer. Otherwise, append ret to ret, and we're going to say a new line character plus the content buffer. So the first thing we append, we set ret to, is just the content buffer. It won't have a new line, and then all the things that come after that, we'll put them on new lines. All right, that's the logic when you find a closing tag, and you complete the closing tag, and then you update your state to the searching for an opening tag, and then all the buffers get set to empty.
So you complete your closing tag, and you perform all these operations. Now, until you find that closing tag, that or that greater than symbol, all the characters are going to be added to the closing tag buffer until you get there. And that should be about it. I'm not sure if there's anything else we really need to do here. Let's see what this does. This compiles. Does it work? What happens? It doesn't compile. Nice. This should be. Oh, how come? How did that happen? Also, man, my neck has been aching me so much lately. I don't know what's going on. An enum switch case label must be the unqualified name of an enumeration constant. Really? Why? That seems incredibly counterintuitive. Okay, that's kind of what they had before, but I don't know if... I don't know, that's just really confusing to me. I mean, I think it looks better, at least aesthetically, but from a functional perspective, it just seems confusing. I don't know if that works also, if that's true in C++. Oh, it's wrong. Okay. None, none, none. Really? At least it compiles and runs. The question, though, is why is this wrong? Okay, let's just put some debug messages in here. Yeah, this is like really involved. This is like a lot more logic than most things that you might do. Okay, searching for opening tag. We'll just make all of these statements speak. All these case statements speak. Validate opening tag. All right, how are we doing here? How are we doing on time also? Hour and 20 minutes. Yeah, I would not want this as a, what do they call that, as a, I would not want this as an interview question. I'd be really annoyed. I would think that would be really kind of excessive. Okay, searching for opening tag, validate opening tag, completing opening tag. Oh, you know what's wrong actually? I know what the issue is. When you validate the opening tag, if it's this, we need to say opening tag buffer. We actually need to add this character. It should actually just be C. Well, we could just plus equals C. Kind of missed that. Okay, now it works. That also is true for the validate. The validate closing tag. If you are completing an opening tag, your opening tag buffer. These really should be reset to the characters. I don't know if you can do it that way. It would be good, but the opening tag buffer actually would be set. This would be like failing the validate closing tag. Or validate opening tag, yeah, validate closing tag, validate opening tag, both of these kind of. Yeah, it's annoying. I mean, you could do this, but I really dislike this. Opening tag buffer for completing opening tag, and then, oh no, it's not, shoot, that's wrong. We're looking for validate, and the validate, this one. Okay, what does that look like? Compiles. Functions as expected. Kind of forgot that that was what we were looking to do. Okay. Oh, well. Let's get rid of these debug messages now. Also, man, I don't know what is going on my neck. Driving me nuts. Drive me nuts. Oh, I missed a few debug messages. Thought I got them all, but okay. Hey, wow, whoa, what? No kidding. Really? What? Alright, I guess we go for it. I don't know. Maybe, hopefully, probably not. Oh. Okay, yeah, of course. Wow. Okay. All the strings challenges in Java. Wow. You know, sure. I mean, what? You could really? Okay. Alrighty. I mean, if I pass that third test case, the one that's got 90 different test cases in there, if it passes that, then I think we're in good shape. I think that's it. But brother, look at this. Look at this code. I mean, look how much time that took to figure that all out, to work through all that. I mean, yeah, you don't have a lot of happening in each section, but it's like 6 different functions you got to write and 6 different states to work through. That is quite complicated, in my opinion. I mean, oh, whoops, do that. Alrighty, let's see. Let's make sure it still works, even though I just removed the debug code. I don't know, man. You know, okay, like that's fine. That's fine. That's, you know, that's. Whew. I don't know what to say about this. This is like, I feel like I just did so much. Feels like I just did so much. 6 different states to work through. For our function, for our parser. It's basically a parser we just wrote, kind of a parser. Yeah, parsing is a pain in the neck. Like that, overall, like just in general, when you're dealing with programs and programming and things of that nature, like parsing and configuration files and parsing those configuration files and having custom formats and adapting to custom formats and making formats and all this stuff, it is generally a nuisance to write that code because it's just something about it. It's very customized. It's very like hard to automate, like the process of setting up the code to do that. Like I really don't know. Like I don't know. It's like a very like a manual kind of a process to kind of put together that kind of a thing. Sort of custom formatted, custom processing, all that stuff. Yeah, really interesting.
Um, yeah, all right. I mean, okay. Okay. Um, I think I want to end it there. I want to just take a nap after that. That challenge is really difficult. What's the next one? What's the next one? Let's just see. Not difficult, but just a lot of effort. A lot of effort. Java interface can only contain method signatures and fields. The interface can be used to achieve polymorphism. In this problem, you will practice your knowledge on interfaces. You are given an interface advanced arithmetic, which contains a method signature and divisor sum int. You need to write a class called myCalculator, which implements the interface. Divisor sum function just takes. Oh, you know, I think I know why my neck aches so much. It's because I'm on this table. I can't. Oh, that's why. I've been trying to figure that out. As I can't sit properly when I have to actually sit up straight in order, because the problem is when I slouch, there's a part of the table that I can't move my leg through. So my right leg is sort of out of position. So when I slouch like that, my whole body becomes contorted because my right leg has to kind of pull back. That's causing my neck to ache. I was trying to figure that out. It's like, why does my neck ache so much? There's that, and also I think just because I'm staring down at a computer screen all day for 10 hours a day, 15 hours a day, whatever it is, and I really need to like raise the screen and also probably stand up too. I think I need to do both of those things. Going to have to figure those things out. But yeah, so, and also probably my arm being, and then my other arm isn't in the same position, so my body's kind of off balance. There's that too. Okay, in this problem, you will practice your knowledge on interfaces. Given interface advanced arithmetic, which contains a method signature int divisor sum. Int of n, you need to write a class called myCalculator, which implements the interface. Divisor sum function just takes an integer as input and returns the sum of all its divisors. For example, divisors of 6 are 1, 2, 3, and 6. So divisor sum should return 12. The value of n will be at most 1,000. Read the partially completed code. In the editor, complete it. You just need to write. Excuse me, the myCalculator class only. Your class shouldn't be public. I implemented advanced arithmetic 12. Divisors of 6 are 1, 2, 3, and 6. 1 plus 2 plus 3 plus 6 is 12. Okay. I actually know this one offhand, like what to do. There's an efficient way to do this. So all you have to do is write a myCalculator. I implemented interface names, myCalculator. What is this? The interfaces ode class get interfaces, the interfaces.length. Interface name equals the interfaces get name, print implemented interface names. Excuse me. Do we need to write the class and then implement the function? Is that what they're asking? Write a class called myCalculator, which implements the interface. Okay. Sure. Okay. Okay. And it's a private class. Shouldn't be public. Okay. I don't know what it is by default, but they don't specify public or private. I guess we do need to make this public because we wouldn't be able to call it otherwise, right?
So so this is kind of neat. So divisor sum. So it's also interesting that they're mixing and matching snake case and camel case here. I think that's also kind of interesting. Also, there's no checks on whether or not this is a positive or negative number. Hopefully this is a positive number only, right? Not negative numbers. Yeah, it would be very confusing what the divisors would be for if you were using negative numbers, what the divisor sum would be. It's really straightforward if it's a positive number, but if it's a negative number, technically you have all of the divisors also have their negations too, would also be divisors if you're dealing with a negative number. So yeah, because you could take all the divisors and multiply by -1, or every positive divisor, make that negate it, and then multiply by whatever the other divisor was, the positive version, and the sum would always be 0, right? So actually, you could just say I think so. And now this is kind of interesting. So watch this. So you can do for int I equals 0, I is less than or equal to the square root of n. Now I don't know, and I'll explain in a moment. Square root function for Java is math square root much lower than int math 4 square root n. Really? But it looks like math dot square root n is what we're looking for. Native implementation. That's a very subtle thing. Native functions, that's something I learned about when I was younger. And apparently native is like the operating system provides a function basically to do okay, so I think this gets optimized out too, by the way. But we can just say upper bound or something. I was gonna say calculating the square root over and over again is not very efficient. But like I said, I think the compiler optimized that out anyway. But we'll do that. We'll just do that to keep things efficient. So, right. So now if, and it's got to be I is 1. So if n modulo I equals 0, if we can divide, now we're going to take our sum, we're going to add I, and we're going to add n divided by I. Right, these two divisors. And that's to say if it's a divisor, we just want to check if I times I equals n, otherwise, so this is kind of a subtle thing, but technically technically, our function, not our function, our integer could be a perfect square, in which case this divisor would only show up once, the square root. So there'd be an odd number of divisors, and so you would want to make sure you handle that case, right? If it's a perfect square, you don't want to add n divided by, you don't want to add this twice. Excuse me. All right, I don't know. I think we go for it. Could be wrong. Nope, we're right. Nice. Sweet. Sweet. So yeah, that's great. Very good. We got another, I don't know, 40 challenges, almost 39 challenges. Not too bad. My neck kind of hurts. I'm kind of tired. I think I want to go take a nap. Yeah. So here we go. Here we are. Very interesting. Okay. All right. So I think I'm going to stop here. I think I'm going to take a break. Yeah, that other problem took really a lot of time. Kind of took a lot of time, and so I want to say like it took a lot out of me because I don't know what that. I don't think so. I don't want to say that. I want to say like I think I'm just really tired. I haven't been getting a lot of sleep the past few days. I had a lot on my mind. Just been kind of stressed, I guess. It's too much, man. Too much in the world. Too much going on. Too many things to think about. Too many things to be concerned about. Gotta trust God, though, right? Just ultimately, just trust God and the Christian God. None of this oneness stuff that you hear some people talking about. I don't know. Talking about Jesus comes with saves you from the wrath of God. All right, yeah. So again, thank you for watching. Talk to you soon. Have a good rest of your day. A good rest of your night. Really don't know what else to say here other than I need to get some sleep. I think the plan for tomorrow is going to be sort of the same as every day. Just keep going. I don't know if I wanted to say this publicly, but I had quit my job, and tomorrow's my last day. So I'm going to have a lot of time from now on to do things for a while at least. I don't know what I'm going to do exactly. I've kind of got like a lot of different ideas and different possibilities and different things I could do or might want to do. So yeah, tomorrow's my last day at my job. That'll be interesting. I have to remember to send an email to the folks that there are quite a few people that I made friendships with over the years there. 6 weeks from now, I would be there for 4 years. So yeah, I don't know. I don't know what I want to do exactly other than I guess Friday I'm going to be plenty of time. I could just spend 10 hours programming LeetCode problems like I used to. Yeah, that'll be interesting. Spend quite a bit of time in the Bible too. And I don't know, maybe I'll just, I don't know, keep I don't know what to do really. Like I said, I'm like, I could keep doing, I could just do LeetCode problems all day for like a few weeks, a few months or whatever, what have you. I can get another job if I want. Can do whatever. I can get another job that pays, like doesn't have to pay very much. My living expenses have been dropped pretty low, so I can pretty much live on anything almost. Yeah, there are some firms that I've been sort of chatting with, I guess, that we'll see what happens, I suppose. But I don't know. I don't know what's gonna happen, what we're gonna do. Yeah, pretty exciting overall though. Like I'm very excited. What else do I want to say? Yeah, thank you all for watching. Talk to you soon. We'll, stay tuned. I guess we're gonna have things in the future. I don't know what exactly, or don't know what's gonna happen, but I'm gonna trust God, and keep kind of grinding away, keep trying, or keep improving. Yeah, keep improving. Okay, all right. Take care. Talk to you soon.